Hello everyone, my name is Joe Scorson, channel is called Ethernet and in today's video we're going to be doing our last new pricing model. We're going to be doing Monte Carlo Simulation to price out contracts. I've done this video before in C++, and that was a super cool video. I dropped a lot of just sauce in that video, but I'm going to do it again in Python, and we're actually going to plot it differently, and then this will be it for pricing models, for new pricing models, but in the next two videos, we're going to be doing applied volatility and then plotting a volatility surface. And so then we're going to have to do it as a chain. We're going to have to store it a little bit differently. It'll be fun. And then after that, we're going to be doing data structures into it, which is like just where my head is at now. We're going to be doing an async cache and then a parallel backtester. And then we're going to be building on that backtester because we're going to make new strategies, put it in the backtester so that we can actually see returns. And then we're going to stress test the portfolio pretty much, which is pretty cool. And before we go any further, I want to thank a viewer of this channel. Let me get your username up here. Your username is HackerBoraBora7212. Just thank you for all the interaction and all the cool support on this channel. You've had a ton of just really cool looking machine learning models in your pocket. And so what I think I'll do, I haven't decided what the two strategies we're going to be testing on the backtester are. Maybe I bring some of the stuff I had later in the plan up, so that way we can fit some other models in there that you mentioned to me. Yeah, so with that being said, this is my business Twitter. Thank you guys so much for getting this over 100 followers. We're at 133. It's absolutely crazy to me. Spaces right up here. We were on it live this morning. I went 0 for 1, but I was right about the direction, but the contract I got was just not great, but it happens. Trade your setups. I saw that setup. I have to take that. Totally okay that I didn't go the way size correctly, and just don't implode. That's the only thing that you can't do as a trader. But yeah, that's the business Twitter, and the algorithm I have with Lux Algo. Algo was also bullish at the time I took that. Things happen. But yeah, if you guys are interested in active trading, check out those two things. I think that you guys will be able to find value in it. So let's hop right into the code. And let's look at our task. Do I have to move my face? No, I'm good. So use the previous option pricing code, but modify the pricing model to use the Monte Carlo simulation instead. Plot everything the same way. Sweet. Simple enough. So the thing I think that you guys should check out first in your code, if you really are just going to Control-C, Control-V, make sure that you name everything correctly. Right. So if you're going to adjust anything to Monte Carlo, make sure that you do it to every function, that you do it in your main, on your plots. If you're going to adjust in your data frame, make sure that you do it correctly. And add these two variables to the parameters in your pricing function. Everything else is pretty much identical. Now, like the last video, we're going to be going along and I'm going to be explaining the code as we go. Because, again, in the literal equation, just as I'm trying to commentate and talk about it, I make a ton of mistakes. So we're just going to cook it like this. So similar to the binomial pricing model, we need the time and the steps. Right, so we need like a factor to go forward by. So that's what this is. We're initializing our random paths right here with the normal distribution. And then we're setting the paths for our spot price. And we're initializing it to be the spot price because we're just going to kind of build off of it, right? So now for all the steps that we have, not for all the simulations, the number of simulations is right there, right? Because we need simulations and we need steps to go in. For all the steps in each simulation, pretty much, we're going to pretty much just move the price forward with this random path, right? So we're going to take the price before it, and then we're going to multiply it by all this, right? So it'll be r minus a half times sigma squared, and then our time step plus our volatility times the square root of our time steps, so like volatility over time, managing like that, and then times the price path that we're on right now. That will give us, actually not that, that will give us the price path that we're going on, price the option to that. So that way, to actually get the price of the contract, what we're going to do, and feel free to pause this, I'm going pretty quickly right now, I know that. But what we're going to do is we're going to get the payoffs of it, and we're going to store it in a array right there. So why are we flooring this at 0? So like our loss is not possible? Of course they are, but we have to floor it at 0 because right here with our discounted payoffs is those option payoffs in the present value, and we're going to return the mean of that as our actual contract price. And so why can't we have like losses show up in the payoffs? That's because we can't have the price of the contract be negative. If we're getting paid to buy options, like I don't care what the trade is, just give me a contract. You know what I mean? So that's why we have to floor it at 0, just a little bit of practicality in the math, and then check out the payoff with the strike price and the last one that we're at, not the last one that we're at the path, just for the whole path, because we have to start at 0, so go to -1, and then just subtract that by our strike price to see if we're actually intrinsically moving or not, if we have a real payoff, and then do the opposite for puts. But yeah, and then discount it to present value, that's what this is, and then return the mean of that, right? And so now let's run this and take a look. There is a randomness involved in it, so I set the seed to be 2024, just because it is 2024. But yeah, here we go. Here is our here are our option prices. We're doing this on Apple right now. But there's some cool stuff in here, like some cool things that you wouldn't really think about. Like right there, that dip on June 3rd, right around here, like just for seemingly no reason, even though the stock is moving up. This is how you can make strategies that simply work off of comparison, right? So actually another viewer that interacts a lot, Hit and Miss Labs, thank you for all the interaction and all the input, was mentioning how I should compare these prices on like the actual CME or Interactive Brokers site to see how accurate we are. The whole point of this series is to like talk about the infrastructure to it, like how is like the literal math going. But these contract prices will never actually be 1-to-1. Could get lucky a few times, but they'll never actually be 1-to-1. And we're going to get way more into that in the next episode when we calculate implied volatility. But to talk about it a little bit, think about the equation of a line, y equals mx plus b. If I have y, m, and x, I can find b. That's the same way finding implied volatility works. Yes, we price the contract with volatility, but then the market trades that price around, right? Rarely are real options the model's price. So then from that, because bid it up, bid it up, bid it up, it doesn't matter if the contract should be worth $1. Someone's willing to pay $1.20, it's worth $1.20. That's the funny thing with valuation. Palantir is at like 76. I'm happy. I have shares in 11, but I don't think it should be worth 76, right? But it doesn't matter because someone's willing to pay that. That's the paradox of valuation. Similar thing with options. And so that's why statistical edges in option pricings exist, because they could be totally independent from the equity, right? Our option prices are so low right here. There could be a strategy where we buy because our option prices are significantly discounting appreciation. I don't know. That's not how I would really make it. If I were to make something like this, I would have something always be low, and then, well, okay, here's the way to do this. Right here, June 4th, $3.87. If the market, and this is a low price, if the market ever priced a contract below that, hit it, right? Because if the market is pricing in lower volatility than my already low volatility strategy or pricing model is pricing in. When I actually put my web app out there, there's going to be a model like this on it. But yeah, that's kind of the whole idea with it in comparing prices and building edges like that. So cool stuff, right? But that is the code on how to implement a Monte Carlo simulation in Python to price options. The code to this and a few of them in the future are going to be in the description below. I encourage you guys to go check that out. I encourage you guys to check out all the work that I do on Twitter with all these awesome people. Even if you don't want to check out me, check out Ace the Kid, check out Bull Trade Finder, check out Paper Gains, and everything I do with Luxalgo. I appreciate if you guys check that out. But that's day 6. I hope that you guys are enjoying the series. I hope that you guys are learning something, and I will see you guys tomorrow. So everybody have a good day.